Hi, myself Dr.G.Tharanitharan. This is a fifth video series of additive manufacturing and its type. Basically, this is a fifth method of additive manufacturing to create a component. The very important process we're going to discuss now. First, uh, laser engineered net shaping method. We can call this method as lens process. What is the beauty of this lens process is uh, it's a it's an additive process, additive technology developed for fabrication of metal part directly from computer design. There is no doubt. And by using a metal powder, here the metal powder is injected into the molten pool created as focus. The high powder laser beam. This technique is also equivalent to the several trademarked components that have the monikers direct metal deposition. We can say as DMD method, laser consolidation, selective laser melting. Objects created with technology can be substantially larger even if the several feet long. This is generally the direct energy deposition DED method we're going to see now is, you can say this same method is powder bed fusion. First, now how this process will work. Now I'm going to explain now. There's a high power laser is usually used to melt a metal powder supplied coaxially to the focus of the layer beam through the deposition head. The laser beam typically travels through the center of the head and is focused to a small spot by one or more lenses. We have XY tables in raster fashion to fabricate each layer of the object. The head is moved up vertically after each layer is completed. The metal powders are delivered and distributed around the circumference of the head either by gravity or by using a pressurized carrier gas. An inert stud gas is often used to seal the metal pool from atmospheric oxygen for better control of the properties and to promote layer to layer adhesion by providing the metal surface wetting. What are the other techniques in the lens process we're going to see now? The process is similar to the other 3D fabrication technologies in its approaches, and it's in the form of solid components by layer additive manufacturing method. Lens process can go from metal and metal oxide powders to metal parts in many cases where the metal is being added of the pots at the moment. It can be produced a part in a wide range of alloys including titanium, stainless steel, aluminum and other specialized materials, as well as the composites and functional grabbed materials. Primarily the application of lens technology include the repairs and overhauls, rapid prototyping and rapid manufacturing, and limited and manufacturing for aerospace, defense and medical markets. Microscopy studies shows the lens part to be fully dense with no composition degradation. Mechanical testing reveals the outstanding as fabricated mechanical product. This process can make near the net shape part, but it's not possible to make an item to the exact specification. In this post production method, light machining and surface machining and heat treatment may be applied to achieve the end compliance to finish these finishing components. This process is as like our powder bed fusion, but here we have a separate loader for loading the powders. We have a one or two laser beam lighters. In that strategy this method will work, but here but in this case of powder bed fusion, we have a in overall surface we're going to spray powder throughout, but here we for the gun will travel based upon the background memory of the CAD model. This is a basic difference between the powder bed fusion technologies and this laser energized net shaping method. Mostly the 20% of the industry peoples are only working this lens process because the cost wise comparatively, like stereolithography and powder bed fusions and laminated object manufacturing and FDM process, this is so high. So mostly rarely used technology to create a complicated parts like turbines. This is a short introduction about the lens process. Thank you.